C double OH group. So first of all, basically it comes a reduction. And we know when you are going to use a strong reducing agent on carboxylic acid, it will be directly converted into alcohol. So you can see RC double OH. If you are going to use a strong reducing agent like lithium aluminum hydride, LiAlH4, ether, or either you can use diborane, which is B2H6, and followed by hydrolysis in the presence of acid, H3O positive. So you can see this part will be directly converted into RCH4 alcohol. So it's very easy. The reaction is very easy. If I have given you CH3, CH2, C double OH, and if you are going to use any one of them, the reagent, then can you tell me the name of the product? Are you done with this?
Are CH3, CH2, CH2OH. Propanol.
Propanol, right?
Yeah.
Very good. So it's very easy. The next reaction is decarboxylation. You have studied this in class 11th as well. That means basically decarboxylation will take place. So decarboxylation, that means CO2 will be lost. Carboxylic acids lose carbon dioxide. Carbon dioxide to form hydrocarbons. To form hydrocarbons. When their sodium salts are heated with soda lime, heated with soda lime, that means basically mixture of NaOH and CaO. NaOH and CaO in the ratio of 3:1. The reaction is known as decarboxylation. And I can show you the reaction. So if you have a carboxylic acid salt, and you are going to react this with soda lime. That means NaOH and CaO in the ratio 3:1, and you are going to heat it. Then you will be getting RH plus Na2CO directly. The carboxylic acid will be directly converted into hydrocarbon. Let me know when you are done with this.
Done.
Very good. Now, after this, the next reaction is substitution reactions in the hydrocarbon part. So as you can see, and in this, the first one is halogenous. The first one is halogenous. So basically, any carboxylic acid having alpha hydrogen will be replaced by halogen. That is your this type of reaction, which is also known as Hell-Wohl-Hart-Jelinski reaction. I'm going to write a point about this. Please do write with me. Carboxylic acids having an alpha hydrogen are halogenated. That means addition of halogen will take place at alpha position, at the alpha position. On treatment with either chlorine or bromine, not iodine or fluorine, either chlorine or bromine, and the reaction will take place in the presence of a small amount of red phosphorus. It shouldn't be more. It should be a small amount of red phosphorus to form alpha halocarboxylic acid. To form alpha halocarboxylic acid. And this reaction is known as Halvolhard-Jelinsky. Reaction. Sometimes it will be written as HVZ. Oh, it's very, very easy. Let me know when you are done with this. Firaz, are you done with this?
Yes.
Okay, so now I'm going to show you the reaction. You just need to find the alpha hydrogen and replace with either chlorine or bromine, whatever is given. So as you can see, this is your carboxylic acid, and you are going to react this with X2 slash red phosphorus and in the second we are going to hydrolyze it. Then you can see this is your main functional group. So this will be your alpha carbon. This will be your alpha carbon. So it has alpha hydrogen, 2 alpha hydrogen. So what you need to do, only take 1 alpha hydrogen out and replace that with X. Then this will be your alpha halocarboxylic acid. Alpha halocarboxylic acid. And X will be equal to chlorine or bromine. Please do write. Write the name of the product. Are you done with this?
Yeah.
Okay. So the last reaction in this chapter. First of all, what is the product that you have got? Have you got this product?
X will be formed there.
Yeah, it is Br, right?
Yeah.
Very. The next reaction and the last reaction of this chapter is ring substitution. And in this ring substitution, you are seeing that this is your carboxylic acid. Do you know what does this COOH is show? What type of resonance, plus R or minus R? If you are going to have this carboxylic acid in resonance, so will it take electron from a ring or will it give electron to the ring? It takes out the electron from ring, yes or no?
Yeah,
so this will be acting as minus R because it is withdrawing electrons, so it will be acting as negative R, and due to this negative R, there will be positive charge on ortho, para, and ortho. And basically, the charge on matter does not take place, or the meta position does not take participate in the reaction, you can say, in resonance. And when you are going to mix concentrated HNO3 and concentrated H2SO4, there will be formation of NO2 plus, which is an electrophile. So this NO2 plus will directly attack on meta group. It will not attack on ortho and para because it has already positive charge, electron deficiency center, electrophilic center, you can say. And NO2 plus is already electrophile, so it will attack where electron rich species are there or nucleophilic center are there. So it will attack on meta position. It will attack on meta position and it will form this compound. Are you getting my point? Yes or no?
Yes.
Please do respond. Okay. Again, if you have this and you are going to react this with Br2 in the presence of FeBr3, so there will be formation of an electrophile Br plus, which will directly attack on meta again, because at ortho and para, it will be electrophilic center. So this will be the product. Please do write.
Done, sir. Yes.
Okay, so here our chapter completed. Uh, Carboxylic acid and aldehyde carboxylic acid and ketones. Let me write the name of the next chapter, amines. Okay, have you studied this chapter? As I told you, so please cover this part. Are you able to see this?
Yeah.
So Firaz, it's a very easy chapter. If you have studied it, you have seen that in this chapter, the amine has 3 degrees. So do you know how to calculate the degree of nitrogen or degree of amine? So basically, first we are going to talk about this degree. Let me wait a minute. It's not showing good. Yeah. Okay. So first I'm going to talk about degree of either nitrogen, or you can say amine, degree of nitrogen or degree of amine. So always remember that to how many carbons nitrogen or amine is connected. Nitrogen is connected or attached directly. Connected or attached directly. So basically, if you are going to see, it's very easy to understand. If this is RNH2, it is connected to only one carbon group, carbon alkyl group. So it is 1 degree or primary amine. We say it is primary amine. If you are going to see RNH, and this is another hydrogen is replaced by R dash, that is 2 degree or secondary amine. Now, if you are going to again, the third hydrogen is replaced by another R alkyl group. So it will be 3 degree or tertiary amine. And we treat this 1 degree, 2 degree, 3 degree amine as different functional group because they react in different manners with the same reactant. Is that clear? Firaz?
Yeah.
So please do write it and let me know so that I can change the slide. Primary, secondary, tertiary.
Yeah, it's done.
Very good. So have you done the nomenclature? Yes or no? Please do let me.
Yes.
You have done the nomenclature. So in IUPAC nomenclature, you have seen that it is alkane amine. Alkane plus amine that will combine to form alkane. Now I'm going to directly give you some question regarding this. Please do write the IUPAC of this step. Are you done with this? Firaz?
Yeah. First is ethanamine.
Just let me know then. Very good. Second,
Pentantoamine.
no. This is secondary amine, and you can see there is another alkyl group and there is another alkyl group. So you have to decide which one is more, which one will be treated as parent chain. So you can see there is 2 carbon here in the alkyl group, and there is 1, 2, 3, 4 carbon. So this will be treated as parent function, parent chain. Yes or no?
Yeah.
This will be treated as substituent. So we are not going to write here numbering. We will directly write N-ethyl and then butanamine. Are you getting my point?
Yeah.
In this, you can see that you have 3 branches. You have 3 chain. This contains 1 carbon. This contains 2 carbon. This contains 3 carbon. So this will be treated as parent chain. Now the rest is your substituent. This is methyl N. This is ethyl E. So N-ethyl, and we are going to write N-methyl, and then come to the parent chain, 3 carbon, that means prop, and singly bonded propane amine. Are you getting my point?
Yeah.
Please do the 4th one. You can use the same concept for this.
N diethyl.
Yeah, N comma N, not N di. N comma N diethyl, and then 1, 2, 3
Propanamine.
propanamine. Are you getting my point? Yeah. Now you can see this will be 1, 2. So it will be ethane 1, 2 diamine. Ethane 1, 2 diamine, because at first carbon and at second carbon we have amine. Are you getting my point?
Yeah.
And here 1, 2, 3. Prop 1. How we are going to write its name?
Two in.
What do you think? Prop 2 in
1 amine.
amine. Very. Now you can see 1, 2, 3, 4, 5. So it will be pentane 2 amine. Pentane 2 amine. Is that clear?
Yeah.
So this is how we do nomenclature. Please do write the name of this also. Its common name is aniline, and now it is treated as IUPAC, or the IUPAC name benzene plus amine, that is benzene amine. Is that clear? Can I change the slide?
Yeah.
No. Now see. Preparation of amines. We are going to prepare amine. And here the first is reduction of nitro compounds. We are going to prepare from reducing nitro compounds. So it's very easy. The reaction in this are very easy. There are two methods in this by using different reagents. So you can see this is your nitrobenzene. And if you are going to react this nitrobenzene with H2 and the presence of palladium and ethanol, then this will be reduced. N2 will be reduced to aniline. This is your aniline. The second reagent we can use for this, as you can see, this is your nitrobenzene. And if you are going to use 10 plus HCl, or either you can use iron plus HCl, this will be reduced, oxygen will be removed, that is reduction, and hydrogen will be added. So in this way, you can convert this into aniline. So this is how we prepare amine by reducing nitro compounds. Are you done with this?
Yes.
Very. Now the next is basically ammonolysis. The next one is ammonolysis of alkyl halides. You are going to react with NH3. Now the first reaction, if I'm going to show you, this is your NH3, which has a lone pair. That means it is a nucleophile. You know, nucleophile is rich in electron, and there is Rx, that is alkyl halide, and you also know that X is more electronegative element, so it will take electron from R. So there will be electrophilic center, and it is nucleophile, so it will attack here. So what it will become, as you can see, this is your R, and it becomes NH3 positive. Yes or no? Since nitrogen donated its electron, so it will have positive charge, and X has negative charge, so there will be X negative. So the bond between NH3 positive and X minus is purely ionic because of force of electrostatic between the positive and negative charge, and the bond between R and NH3 is coordinate bond, which is what we say covalent bond. So we can also write substituted ammonium salt. Also, it's very important to note that, please focus here. If you have RNH2, that means you have 1 degree or primary amine, and you are going to react with RX. Just focus here, then you will write RX. So what will happen here? Here, X minus will be eliminated, and one of the hydrogen from here will also be eliminated in the form of H plus, or you can think of like this: R will substitute one of the hydrogens. So here it will be R2NH, and X and H, that is substituted by R, will form a byproduct HX. Again, Rx will be reacting with this. Again, you are going to replace this hydrogen with R, so it will be R3N, and this has a lone pair from the starting. And again, if you are going to do this with this, you can see there is no hydrogen. So what will happen? This will take electron from here. X will take electron from R, so there will be positive charge and it will attack on this. So it will be R4N positive and X negative. You can see this will be the formation of 2 degree amine, this will be the formation of 3 degree amine, and this will be the formation of quaternary ammonium salt. Quaternary ammonium salt. So please do write. Let me know when you are done with this. Are you done with this?
Does.
Wait a minute, please. Okay, thank you. Thank you for waiting. So you can see, Firaz, have you any doubt in this? Firaz, are you there?
Yeah.
Okay. Now you can see that if you are going to react this, Rn is 3 positive, X negative, which is quaternary, not quaternary, ammonium salt it is. And if you are going to react this with base, then you will be getting primary amine, RnH2, and the rest H2O will be eliminated from here, H2O, and then Na plus X minus will form. So basically with ammonolysis, the major product will be your 1 degree or primary amine from ammonolysis, because you can see it is started from primary amine, then converted into secondary, then tertiary, then quaternary, and this will be the least, then this, the major will be primary amine. Is that clear?
Yes, sir.
Can I change the slide?
Yes, sir.
Okay. Now the next preparation of amine is reduction of nitriles. Reduction of nitriles. And how the reduction of nitriles take place? It's very easy. RC triple bond N. And if you are going to react it with H2 in the presence, or either you can use sodium amalgam in the presence of alcohol C2H5OH, then it will be converted into RCH2NH2. I'm just going to explain the reaction. You can see if you are going to break one of the bond, there will be addition of hydrogen here and here, and another reduction, that means addition of hydrogen. Now you can see RCH2NH2, it converted into amine. Is that clear?
Primary amine, right?
Yeah, primary. Please do it.
Propanamine.
What you just said?
Propanamine.
Propanamine. Very good. So you can say this will be directly converted into CH3, CH2, and then CH2 again, and then NH2. So it is propanamine. What about this? This is alkyl halide, this is amine. So what you need to do, just remove this chlorine and remove hydrogen, and you will be writing it C2H5NH2, right? The byproduct will be HCl. Are you getting my point?
Yeah.
Now again, C2H5Cl and this amine, this Cl will be removed with one of the hydrogen. So what you will be getting C2H5 and then NH and then C2H5. Then again reacting with this chlorine and hydrogen will be removed, and you can see this become tertiary C2H5N, and there will be C2H5, and then there will be C2H5. Are you getting my point?
Yeah.
So it's very easy. Let me know when you are able to see this thing. Now you are able to see this thing. Now again, if you are going to react with this, you can see there is a lone pair.
Yeah.
So it will attack on this carbon and become C, which the whole thrice was already there. Now it becomes whole 4 and N positive and Cl minus. So quaternary ammonium salt. This is how the reaction will take place. Please do write it.
Actually, C2H5 thrice, right?
No, whole thrice was already there. No, you can see this is N already C2H5, C2H5, and C2H5. Whole thrice is there. And there is nitrogen which has a lone pair, and you are going to react this with C2H5Cl. Cl will be eliminated in the form of Cl minus, so there will be positive charge, so it will attack here and N becomes positive. Now C2H5, C2H5, C2H5 whole thrice and C2H5. So it will become C2H5 whole 4 and positive Cl minus. Are you getting my point? Let me know when you are finished with this or you have any doubt. Are you done with this? Are you done with this?
Yeah.
Very good. Now the next reaction is basically a reduction of amides. Next preparation, and we do it by reduction of amides. And see how the reaction will take place. This is your amide RC double bond O NH2, and you are going to reduce it with a strong reducing agent, that is LiLH4, followed by hydrolysis. So how the reduction will take place? First, this bond will be broken, hydrogen will be added in oxygen and carbon. Another bond will also be, and in this way, you can easily break this or convert this into amine, and H2 will be eliminated. So I think the reaction is quite easy, right?
Yeah.
Please do. Let me know when you are done with this.
So propanamide again.
Yeah, it will be propanamide like this, right? This will be converted into H2 and this will be converted into H2. Very good. So can I change the slide?
Yes.
Now the last preparation, second last. This is your Gabriel Halimide. You have seen this compound in the previous chapter, Halimide. So from Gabriel Halimide synthesis, first I'm going to write Halimide. So this is your Halimide.
It's like anhydride group, right?
What is anhydride?
It's like anhydride group, right? The
Yeah,
structure.
it is like that. Yeah. So this is your Halimide. So what we are going to do, it's very important. You are going to react this with KOH, and this K will replace this hydrogen and it will form, as you can see, this is your C double bond O, C double bond O. And then there will be N negative, more electronegative, and K positive. Now again, you are going to react this with RX, that means alkyl halide. If you are going to react this with alkyl halide, this will have negative, this will have positive. So this positive will go to this. So what you will get, you can see, this is what you will get. So there is C double bond O, there is C double bond O as it is, and then there is N, and then there is R will go to this, and this X and this K will become salt and eliminated. Now this has a name which is alkyl halide, an alkyl halide. Now see, again this part will be reacting with alkalis, that is sodium hydroxide in aqueous. Then you will be getting as a main product that we are going to prepare RNH2, and this is your 1 degree or primary amine. Primary amine. And as a byproduct, you will see a compound that I'm going to write. So this is the byproduct. C double bond O, and again C double bond O, and there is O negative and a positive, which is a salt. By this method, we are able to prepare only primary amine. Only primary amine. I think it's very easy. Are you done with this?
Done, sir.
Very good. Now the next is the sixth one is Hoffman bromamide degradation reaction. So in the name you can see it's degradation. That means the number of carbon that is present in reactant and the number of carbon in product will be lesser than or lesser by 1. So as you can see, this is your amide, and if you are going to react this with bromine in the presence of alkalis, that means base, so this carbon will be eliminated and this R will be directly attached with NH2. So it will be like this, and you can see this NaOH, Br2 and C double bond O combine together to form this is Na2CO3. This is your Na2CO3 along with 2 NaBr, and there will be formation of water as well. So always keep it in mind that there will be degradation in carbon. One carbon, the number of carbon present in product will be lesser by 1 as compared to the number of carbon in product. Are you getting my point?
Yeah.
Okay. Please do write it. So you are available on Sunday, right?
Yes, sir.
So there will be an extra class at same time, like today.
Okay. Done.
Very good. So the preparation, we are done with the preparation also. Now, there will be physical properties, and you can see in physical properties, can you tell me, this is your primary, arrange in decreasing order of intermolecular hydrogen bond. If you have primary amine, if you are having secondary amine, if you are having tertiary amine, which one will have the most hydrogen bond?
Primary.
Primary amine, because two hydrogen is free, so it will have the most, then this, then this. Please do write it. So due to hydrogen bonding, boiling point also increases, right?
Yeah.
So this is it for today. Before that, I would like to ask some of the question. Can you arrange this in increasing or decreasing order of boiling point? If you have C4H9NH2, then you have C2H5 whole twice NH. Then you have C2H5 N and CH3 whole twice. Which one will have the most boiling point?
The primary one. Before H9.
This will have the, this is basically all the compounds that I have given is comparable atomic masses, molecular masses. So it will have more hydrogen bonding. So it is then this and then this, right?
Yeah.
Is that clear? Okay. So in the next class, you are going to study about the on Sunday chemical reaction, and in chemical reaction you are going to study about the basic strength. It's very important, and basically there is no trend in this. There will be exception, not the exception. Basically the basic character depends on more than one factor. That's why the variation you will see. Are you getting my point?
Yeah.
Generally what happens, basic character is directly proportional to plus I, as I have already told you. So this is your RNH2. I'm going to take this as CH3, and this is your CH3NH, CH3, and this is your NCH3, CH3, CH3. So the expected answer is this will be the most, and then this. Are you getting my point? Because it has plus I effect from one side, this will be from two side, and this will be from three side, right? But still,
Yeah.
this will have the most basic character. This is the expected, which is wrong. But practically, we will see that this is wrong. So I would recommend you to please read about it. So